So I was telling about the theory of this minimum boiling point azeotropes. So these azeotropes are found by the binary solution which show large positive deviation from the Raoult's law. This type of azeotropes corresponds to such a composition of the solution which has maximum vapor pressure and hence the minimum boiling point. So I told you earlier that maximum vapor pressure, why they have maximum vapor pressure, because they start vaporizing off earlier or at room temperature, or their vaporizing point or temperature is very less, like ether. So they have a vapor phase maximum vapor pressure, and the boiling point of minimum boiling azeotropes is less than that of either of the pure component, that is A or B. So boiling point is less than the pure components A and B. The boiling point composition diagram of such solution show that for one of the intermediate composition C, the total vapor pressure of the solution is highest and the boiling point is lowest. At this point, the composition of liquid and vapor phase is same, and the liquid mixture boils at a constant temperature and remains unchanged in the composition. Therefore, this liquid mixture distills over as if it is a pure liquid. So I have shown you here the vapor boiling point composition diagram of ethanol and water from the minimum boiling azeotrope. So it has a maximum in the vapor pressure curve. So this is the maxima in the vapor pressure curve, and hence a minimum in the boiling point diagram as shown in this figure. So boiling point, why it's low, it's have a minima in the boiling point, because they are easy to evaporate. This ethanol is easily vaporizes off. So ethanol and water for minimum boiling azeotrope at a temperature of 351.1 Kelvin, which is lower than that of pure ethanol and that of water. So the fractional distillation of ethanol and water mixture can concentrate the alcohol to the azeotropic composition. Once this composition has been attained, the liquid and vapor have the same composition, and therefore it cannot be further distilled to separate water from ethanol. So this was the minimum boiling point azeotropes. So maximum boiling point azeotropes are, these azeotropes are found by those liquid pairs which show negative deviation from the ideal behavior. The maximum boiling points azeotropes are those azeotropes which are found by those liquid pair which show negative deviation from the ideal behavior. So they shows the minimum boiling azeotrope show the positive deviation from the ideal behavior. So in such solution, there is a diagram which explains itself everything. The boiling point of the solution is higher than the pure components, that is boiling point of HCl is 188 Kelvin and boiling point of water is 373 Kelvin, and their mixture at this particular composition where mole fraction of X and X HCl and X water are fixed, at this point the boiling point of this is 381.6 Kelvin, and they have low vapor pressure, so they show the maxima in the this boiling point curve. So I don't think there is a need to explain this diagram again. It is similar to this. The only difference lies here. This is the minimum boiling point azeotropes as this has minimum in the boiling point, whereas it is a maximum boiling point azeotropes. So you can repeat it or revise it, then you will be more clear about it. And always remember that the in solutions the most important topics are the Raoult's law and the basics like molarity, mole fraction. You will find again and again mention of the word mole fraction and molarity. So next time we will take completely miscible liquids.